Hey guys, just jumping in to do a quick little video to cover some of the problems that I noticed you guys had a little bit more difficulty with as I've been sort of grading through. I'm kind of going to jump all over the place and just do a quick little hodgepodge. The very first problem that I noticed is actually solving word problems. All of you, to some degree, did not enjoy solving some of the word problems. So I'm just looking at chapter 2.8 because just kind of want to quickly walk you through just some logic and how to solve some of these word problems. So I'm just going to jump in and do problem number 23. Several of you missed this problem, and I just wanted to cover it. It's on page 82. It's just a story problem, and we just need to be able to determine how to solve this problem. It says a tour bus averaged 50 miles per hour between two cities on the first leg of a trip and 45 miles per hour on the return trip. The return trip took 1.5 hour longer. Find the distance between two cities. So basically, I have a city here and I have a city here. And when the bus was going this way, he averaged 50 miles per hour. And when the bus came back, he averaged 45. Plus, it took him an extra half an hour. So let's kind of like just process this down. First off, the distance is the same both ways. So I can set my equation up so that the distances equal each other. If you want to look at that mathematically, it'd be the distance of trip 1 is going to equal the distance of trip 2. Now, what actually should I include in this distance? Well, distance equals rate times time. The rate is going to actually be the speed, the miles per hour, okay, for both of these sides. So I'm going to separate this out, and I'm going to say rate of 1 equals the time of 1. That's the first trip, this one. Rate of 1, rate times time, basically is what I'm trying to say. And then the second trip, I'm just using these sub 2s because it just shows that I'm working on a second trip, okay? So this is trip number 1, so these are all my sub 1s, and this is trip number 2, and this is all my sub 2. Now, I know that this rate for the first one was whatever it is. The t here just equals x, like it's just whatever the time was, or I could use t, whatever I want to use, okay? That just is what it is. And this one is whatever it is plus a half an hour. So whatever it is plus a half an hour, because it says it took a half an hour longer. So when I'm setting this up, I want to be able to balance this out pretty easily. I'll start here. Let me grab a different color. On this side, okay, if I'm just looking at this one, then what I'm going to have is 50, and let's just stick with t, 50t. So I have 50 times, 50 miles per hour times however much time it took me to drive between the two cities. And on this side, trip 2, I'm going to have 45, and I'm still going to have t, but I'm going to have t plus a half an hour, okay? I'm going to have basically, I'm sticking with the t here, so t plus a half an hour. So I have to link this together. I have to put this in parentheses. So here's my basic equation that I'm working with. The first trip, driving 50 miles per hour for a certain amount of time, and I get to the second city. On the way back, I'm driving 45 miles per hour for a certain amount of time, plus that extra half an hour. Okay, so now let's just start solving some math, okay? So 50t is not going to do anything special besides just stay 50t. For 45 times the quantity of t plus 1/2, I have to distribute here. So I end up with 45t plus, what is half of 45? Well, it's 22.5 or 22.5. It doesn't matter. I favor decimals. And now I'm going to end up with, I want to move my t's to the same side. So I'm going to minus 45t here. And remember, what I do to one side, I have to do to the other. So I'll minus the 45t on this side. So that means now I have 5t equals 22.5. And 5t means 5 times t. I want to do the opposite, the inverse operation. So the opposite of multiplication is division. So I have to divide both sides. Boom, that leaves me with 10 equals, and if I want to put 22.5 into my calculator and divide that by 5, I'm going to come up with 4.5 is what t equals. So that basically means that my trip, my D1, my trip for the 50 miles per hour is going to be 50, that's an ugly O, but 50 times 4.5. So 50 miles per hour at 4.5 hours is going to give me my total trip. I think it's 225. Let me put it in here. 50 times 4.5. Yeah, it's 225 miles. So 225 miles is what the distance is. And I could do it into the other one, but it would just take longer. I would have to multiply that half of an hour back in. All I'm really looking for is just the distance anyway. So it's 225 miles as my distance. So this is how I set my problem up. I'm trying to walk you through what I do so you can sort of hear my logic. Let's do number 24, and then we're going to jump out of problem solving. An automobile driver traveled the first part of a 400-mile trip. Okay, so the trip was 400 miles at an average rate of 50 miles per hour. So there's two parts. The first part he's traveling at 50 miles per hour. Upon reaching an interstate route, his average speed increased to 60 miles per hour. His total travel time was 7 hours. How far had he traveled when he reached the interstate route? Okay, so there's a trip. Okay, I have no idea where it is, but there's part A and there's part B. And we know that the total thing is 400 miles. And we also know that it took 7 hours. Let me double check that that was the whole trip. His total travel time was 7 hours. Okay, so let's just try to label things. Okay, remember when we're talking about distance, we're going to add, when you talk about distance, you're looking at rate times time. Okay, in this particular situation, I actually have this distance that I'm going to have to add to this distance to get this total. So I'm going to actually end up with like an R1 T1, and I'm going to need to add in R2 T2 because I have two trips. Okay, this is the one that's number 1, and this is the one that's number 2, and then we're just going to put them together, and I'll get my total distance. Or I'll be able to figure out actually what it's asking for is how far had he traveled when he reached the interstate route. Like we're kind of looking for this. When was this? Okay, so D is going to be 400, so I can go ahead and just put in, remember we said the total right here is 400, so I'm just grabbing that number and I'm able to drop it in. Okay, rate of 1, we look back at our problem and we were running 50 miles per hour. So here's my rate. So I'm going to have 50 times time of 1. And I don't know how long that was. I just know that it equals up to 7 eventually. And then add that to my rate here, which was 60 miles per hour. So I'm going to have 60. And here it's going to be 7 total minus, where am I getting the 7? Right here, because it's 7 total hours minus whatever in the world T1 is. So T2 is like, the first half took a certain amount of time that I don't know. So I'm going to call it T1. But I know that the whole thing took 7 minus whatever that was for the second half of my trip. So I know it's a little bit tough and you have to follow that logic, but it's not too terribly complicated. Okay, 400, just doing my math now. I'm just going to 50 and I'll just drop my T1 outside of it. It's not a big deal. 50 times T1 is just 50 T1. Plus, I'm going to have to do some distributive property here to break out this parentheses. And 60 times 7 is 420. And then 60 times a negative T sub 1 is going to be a negative 60 T1. Now I want to get my T's together, so I've got to look at my like terms here. I have a 50 T1 and a negative 60 T1. So I probably want to move some things around here. I probably want to try to move them both to this opposite side. Let's see if I can get them together here. If I combine them, I'm going to end up with a negative 10 T1. I know I don't want my number to eventually be negative, so I'll do some flipping here in a second. Plus 420 equals 400. What I would really like to see happen is for this to go over here and for this to come over here. So I'm just going to do that. Okay, so I'm just going to add my 10 T1 and add it over here. And at the same time, I should have made this smaller, but I'm going to subtract my 400 and I'll subtract this 400. So I'm literally just swapping sides and swapping signs is what I'm doing. But I'm trying to show you my math. So that gives me a positive 10 to the T1 on this side. And then because I moved the 400, it's a minus 400. So 420 minus 400 just leaves me with 20. So now all I need to do is just divide. I have to get rid of this 10. And these are going to cancel. So that means my T is going to equal 2. So I have a T, this time is going to equal 2. So when I go back and I try to figure out the distance of this first half, if you remember, this was it right here. So my D equals that 50 miles per hour that I was driving times the 2 hours, okay, times the 2 hours, and that's going to tell me that my distance was 100 miles. So I traveled 100 miles. So basically, of a 7-hour trip or a 400-mile trip, from here to here was 100, and then from here to here was 300. But I don't have to know all that. I just have to know that the first half was 100 miles. I know that's a lot to do, and it's a lot to process. These story problems aren't completely unsolvable. They're just challenging. So you have to really think through the scenario. Sometimes just setting them up is the most difficult part. So go back over the last couple of lessons and use an example if you need to. Okay, so I'm going to move on to page 90 really fast. I had a note here to myself. So review of one variable linear, I can never say that word, equations. And it's on page 90. This is kind of our chapter 2 test. So I want to go ahead and take a look at that. There's a couple of problems here that seem to give everybody some trouble. I'm going to look at problem number 50. Actually, I'm going to look at problem number 51. So let's see what we have for 51. So 51 is another story problem. So these were really what was most challenging for you guys. So I'm doing page 90 and 91. This was your chapter 2 test. And I'm solving problem number 51 because there seemed to be some difficulty with that problem. Find 3 consecutive numbers whose sum is 51. Okay, consecutive means that they go in order. Okay, so I'm going to have a first number, a second number, and a third number because it says find 3 consecutive numbers, right? The thing is I don't know which numbers to start with. I don't know what the first number really should be. If I knew the first number, I could probably figure out, well, the number right after that and then the number right after that. And I know that the sum, if I add them all up, it has to equal 51. So since I don't know my first number, but if I did, it would totally help me out, I'm just going to say my first number is going to be X. That's my unknown. That means my second number has to be X plus 1 because they're consecutive. So I'm just picking a number. Let's just say my first number was 5. Then the second number has to be X plus 1 because that would be 6. And then the third number has to be X plus 2 because that would be like 7 if 5 happened to be my number. I don't know. Maybe it is. Let's find out. So now what I need to do is I need to just add all these up, right? The sum is 51. So I'm just going to set this up. X plus 1 plus X plus 2. And this whole business is going to be added together and it's going to reach 51. So I'm going to combine some like terms here. I have an X and an X and an X. So that's 3 X's. Plus I have, I'll do a different number, different color, I'm sorry, a 1 and a 2. So that's going to give me 3 equals 51. Now remember, you always want to end up with the X by itself. So I'm going to subtract this 3, and what you do to one side, you have to do the other. That's the golden rule. So 3X equals, this is 48. Now, right now I have 3 multiplied by X, and the opposite of multiplication is division. So I have to divide. That's going to cancel these out and leave X all by itself. And 48 divided by 3 is 16. Now, what in the world does that mean? Well, let's go back up here. Let me grab my eraser real fast. Okay, we said X was equal to 16, right? So since X is equal to 16, this first number is 16. Okay, 16 plus 1, so the second number is 17. and 16 plus 2, so the third number is 18. So let's check. Are they 3 consecutive numbers? Yep. Do they all add up to 51? 16 plus 17 plus 18 is 51. So that's my final answer. So again, it takes a little bit of time just to think through what's being asked of you, but they're not too terribly hard if you just try to follow what the question is actually asking of you. The next one I want to go over for you is page 114. 114 is the review of graphing linear equations, and this is kind of like test 3 part 1. So if you're looking back at your notes, it's test 3 part 1, and it's page 314. I'm going to flip to it in my answer book because I do not want to tell you wrong. And if anybody has a different question, like if you're solving some problems and you run into a question and you want me to solve it for you before you start taking your test, I'm happy to do that if you need me to review something else. So I'm really just reviewing what a couple of students specifically asked me to review. So if there's a concept that you don't understand or you feel like, wow, it would really help me if she would do one of these problems and kind of give me an idea, I'm more than happy to do it for you. Just shoot me an email or shoot me a text message and I can make a quick video. Okay, so I'm on page 114. So 114 is all the graphing business. And if you kind of follow the directions all the way towards the end, you get to where it's asking you to use the slope-intercept form. So I had a student ask me to work a couple problems using slope-intercept form. And if you just take just a second and you kind of go back, I'm working backwards now. I want you to go all the way back to 3.4. Because 3.4 gives you the first form. That's the slope-intercept form, which is what we're going to need to know. And you can see right in that box on the top of page 106, it says slope-intercept form. And there you go. It like shows you y equals mx plus b. Right? If you make sure it didn't want you to do it in point slope form. Yeah, slope-intercept form. So on page 106, you see slope-intercept form. It teaches you exactly how to use this form. There's another one called point form. Let me tell you exactly what it is. It's the slope of a line form. It's the slope equation. You can see that equation on page 102. That kind of gives you an idea if you need to go back and use that one. It's back again on page 104, back in that yellow box. Each of these lessons kind of give you the formula that they want you to use. So just go back and review it. Your test is open book. Go back and use those formulas and let them help you. Okay, I'm on page 114 and I'm going to do problem number 35. Okay, so 35, it says write the equation of each line in slope-intercept form. Okay, I flipped back to my slope-intercept formula on page 106, and I see that my slope-intercept form is y equals mx plus b. Okay, y equals mx plus b. I want to make my equation look just like that one. So here's the information that I have. They say, hey, we'll go ahead and tell you the slope, and the slope here is 1/6. Okay. And they also give me a point. So I have a point, which is 4, -3, and I have my slope. So I need to write an equation that would work with that information. Okay, so I could use my y equal mx plus b form, but to be completely honest with you, it would even be easier just looking at the information that they gave us if I set it up with my point slope form version. So I'm looking back at 3.5, page 110, and you can see the very first example, 3.5a. They use y equals mx plus b, and then the very next one, they give you point slope form at the top of page 111. They just manipulated the form a little bit so that if you only have a slope in one point, but it's not a y-intercept, okay, so hopefully you understand what I'm saying. This is the y-intercept, so that this means you would have a 0 and whatever in the world y was worth. Okay, but since this is not a 0, it's kind of like I have to do an extra step before I can just use this formula that I absolutely love because it's easy to use. So instead of being able to just jump right into this formula, I need to use my point slope form. And if I use the point slope form, then I can set it up really easily and I can have it knocked out. So here we go. Y minus y sub 1 equals m, and then x minus x sub 1. Now, okay, kind of a reminder, the way I kind of think about this is they gave me a slope. Okay, cool. And then they gave me 1 point. So since they gave me 1 point, I want to use my formula that has my 1 point, a y1 and an x1. That kind of helps remind me, like I need to use a formula that has the extra y point and the extra x point so that I could drop my points into this equation. Okay, fine. So y minus, here's y sub 1. So y minus a negative 3 equals m, I'm not going to do it yet. I'm not going to put it in yet because I want to explain, times x minus x sub 1, which there it is, my 4. And hopefully you didn't have any problem realizing that 4 and negative 3, that this is my x and this is my y, because this is how we always do it. And I put the little 1 here because it's the only point they gave us. Now, something that I didn't do the first time through because I didn't want to get too wordy is I didn't add in the slope. Well, slope is always the m. So I'm going to take my eraser and I'm going to back out my slope, my m, and I'm just going to put in what I know it is. It's 1/6. So 1/6 is my actual m value. Now I just need to tidy everything up, okay? Y minus a negative 3. Y minus a negative 3. Make sure I'm doing the right one here. 4. Okay, perfect. So y minus a negative 3, this is actually a plus sign because if we're getting rid of a negative, then it's like adding it. So I have a y plus 3, try to write small, equals 1/2 6 x, 1/2 x minus 4. So I want to get this x minus 4 by itself, okay? So instead of distributing all this out, the way my brain wants to do it is this says 1/6 times x minus 4. I just want to divide this whole mess by 1/6. And I want to divide this whole mess by 1/6 because what you do to one side, you have to do to another. So in order to balance all this out, when you have y plus 3 and you divide something by 1/6, anytime you're dividing, you multiply by the reciprocal. So I'm going to try to make some room up here. I didn't do a very good job of saving space. So I'm going to make some room and I'll change colors. So what I have is y plus 3 times 6/1. Okay, that's what I have. And I can actually set this over 1 if I want to. That's on one side. And then the other side, these are going to cancel. This 1/6 is going to cancel, and I'm only going to have x minus 4 on this side. So here I just straight multiply this. So I say 6 times y plus 3. And all that's over 1, so I'm just going to, I don't need that 1, minus 4. And that's where I'm at with my problem. I'm going to have to distribute. So I have 6y plus 18 equals x minus 4. Now I want to get, this form right here, y equals mx plus b. Oops, right there. So I kind of want to just start moving stuff around. I want to get rid of this 18. So I'm going to minus it on both sides. So now I have 6y equals x, minus 22. Now I have, this says 6 times y, so I'm going to divide by 6. I'll divide by 6 here. This is a 1x in case you guys were wondering. So I'm going to end up canceling these out. And if I want to divide each of these out, because I really want to have like this fraction going on here, that's what I'm trying to get to, because remember, here I am. So I knew I was going to end up with a 1x6. And then, I'm sorry, a 1/6x. And I still have my minus side. This is actually a 22/6, but this can be reduced to 11/3. So my final version will be y equals 1/6x minus 11/3. And that is the final big poo-ha for this problem. So my entire goal in this problem was to get it into this form based on the information that they gave me, which was the slope and 1 point. And since they only gave me one slope and 1 point, I just jumped back to my little cheater chart, which is table B on page 112. You could totally use it too. And there it is. I've got a point and I've got a slope. So I'm going to use the point slope formula. And there's my point slope formula. And I just dropped everything in and literally just solved the math for y. Okay, I hope that wasn't too confusing. I think that kind of just covers a couple of things that I wanted to go over. Again, if there's a specific problem that it would help you be more successful on the test, I am happy to solve it for you. Send me an email or shoot me a text message and say, please solve this problem because there's one just like it on the test and I don't know how to do it. Good luck on your test.